Here we go. All right, so homework 20 or 2.4. This is 21 through 33. Okay, and this is factoring. Okay, so since you all need a review on factoring, this is what I call my 5-step method. We will not use all 5 steps until we get to this one. Okay, so this will be the only 5-stepper. So in order to do that, I'm going to write all 5 over here. The first step is GCF. The second step is parentheses star variable. Okay. The third step is signs. The fourth step is product and sum. And the fifth step is star cleanup.
What did 2 say?
What?
What did 2 say?
Number 2 says parentheses,
Yes.
star, variable.
So
So what number 2 was it kind of incorporated 5 steps in one. Like I said, this used to be a 28 to 25 step problem, and I turned it into 5 step. Okay? Now, most of the time you're only going to use 3.
is that
Pi, yeah, pi and sigma. Most of the time you will only use 3. The 3 steps you will use most of the time are 2 through 4. Okay? Let's take a look at this first one, and I'll show you what I mean. Okay? Very, very, very easy. The first thing you need to think about if something is factorable, okay, is the product and the sum. The product and the sum. Okay? What multiplies to be 24 but adds, in this case, because of that sign, adds to be 11. What?
3 and 8.
3 and 8? Okay. Always big number first.
Okay, 8 and 3.
Perfect. Thank you. So 8 and 3. So right now, we know that this is factorable. If we start with that, it's cake. All right? Let's eat some. Let's go. Well, what's the first step? What's the first step? Right? GCF, right? The GCF, what goes into each of these?
8.
What goes into 24, 11, and 1?
1.
1. So there's no GCF. Okay? Is there a number out front?
Oh, wait, I know what GCF is. I know that.
Is there a number out front? 1, right? So there's no star. So now we move on into just the parentheses and the variable. We take this variable and square root it. Okay? So if there's 2, then we'll have 1 in each. If there's 4, we'll have 2 in each. If there's 6, we'll have 3 in each. See what I'm saying? If it's x to the 6th power, you'll have x to the 3rd power in each of these. What you guys will be seeing mostly is x squared, and so we'll have an x and an x. And that's it. That's it. That's your step. It's that simple. Okay? Next, signs. I'm going to take this first sign, and it's going to come down. Can everybody do that? Bring that first sign into the parentheses. It's that simple. Okay? Now, this sign right here tells me if these signs right here are the same or if they are different. Okay? If this sign is a plus, they are the same. If this sign is a negative, they are different. It's that simple. So I look at this sign and it says, oh, it's plus. It's a sum. So they are the same. Right? So these two are the same. So if this is a plus, then this has to be a plus. Okay? They are the same. Alright. Product and sum. Product and sum. What multiplies to be 24 and adds to be 11? So two numbers that multiply to be 24. It could be 6 and 3, or 6 and 4, right? Could be 8 and 3. In this case, 8 and 3 adds to be 11. Okay? So, we plug in 8 and 3. And that's done. That's it. So, okay? Because the big number always goes first.
How do you know how to get those?
Huh?
How do you know how to get those?
How do you know? Oh, like what multiplies? So think about what multiplies to be 24. So it could be 6 and 4, right?
Plenty of numbers.
Could be 12 and 2, right? Or 1 and 24.
It's because you FOIL it.
But if you just add these, do they give you 11?
Is that what that is? What is that? That little thing right there.
This?
Yes.
Sum. It's a sum. It's sigma.
So that's like a symbol for sum?
So later on you'll be doing what's called summations.
Okay, I need to put that. Sigma notations. Ugh. Wait, in this class?
No. Pre-cal.
So for everyone, you're going to try to find the number that equals to the B.
Yes. We just want which one of these equal 11 when we add them. So when you add them, which one adds up to be 11? Well, this one is 10, right? This one is 14. This one is 25. We want 11. This one is 11. So that's why we choose 8 and 3. What?
There's none of them that adds to 11.
Then it's not factorable.
So that's just stupid. And you're just done.
Well, it's called prime, not stupid.
But then you're done.
But then you're done.
Okay.
Okay? All right, next. Remember my first step? What's the first step? GCF. All right? Probably none of you seen this because you don't have me. Right? But I'm going to show you upside down division. We talked about it maybe when we were doing, did we do square roots yet?
I don't know.
No? Okay. That was pre-cal. All right, so upside down division. It's really simple. Right there. It's an upside down division sign.
Okay.
Why would I do that? Because I want to know what goes into both of these. What goes into both of these?
What are you pointing at?
Now you don't want the negative out front. So you'll want to pull out a negative. Practice this. This is huge. When you get a factor by grouping problem, I guarantee you they're going to make you want to pull out the negative. Alright? So, what is in both of them? X, right? There's an X in both.
That's not upside down division.
Prime factorization, right? So, divide by a negative X, what's left? What multiplies by a negative X to give you an X squared?
X.
X. What multiplies by a negative X to give you positive 9X?
Negative 9.
Okay? And so now you just factored it. It's done.
Kind of like at least they're not doing whatever it's called where they have to bounce so many numbers like a basketball.
Yeah. I don't teach that way.
Thank you.
Alright. Next. Is this factorable? Let me ask you. What is the product? What is the sum? Okay? In this case, what multiplies to be 8 and adds to be 7? Because we have to use this guy. Now 1 and 8 subtract to be 7. Did I copy this down wrong?
Negative 1 and negative 8.
Nope, that would be negative 9.
Wait, oh yeah.
So what multiplies to be 8? So we got 8 and 1. We got 4 and 2, right? Anything else? No? Okay. Which one of these adds to be 7? None of them. it. And because it's prime, we would use what's called the quadratic formula. Okay? But we won't do that now. Now, did I copy this right? Something tells me it's not copied right. Aha! It should be -8. Okay? So this should be -8, guys. Focus. Guys, pay attention. We copied it down wrong. This should be -8. So now, what multiplies to be 8 but subtracts to be 7?
8 negative 1.
8 minus 1, right? So in this case, I'm going to use this sign as a minus sign. I don't use negatives and positives and all that. I just want to know what subtracts. I keep it really simple. What subtracts to be 7? 8 minus 1. That's it. And so when you do this, it's the same thing. The first step, parentheses, variable. What is the first sign? What is this first sign? You just bring it down. Bring down the first sign. The second sign tells me if these are the same or different. What does a minus sign tell me?
Different.
They're different. So what's different than plus? Minus.
But I thought if it was plus, it was...
So this is where it gets confusing, but try to keep it simple. What's different than the first sign? If it's different from the first sign or same as the first sign. Okay? So it's different, so it's minus. That's it. Keep it simple. Now, what are our two numbers we came up with? 8 and 1. Which one's bigger?
8.
And put 8 in first. Done. That's it. Every time. This is easy. This is cake. Eat it up.
I wish he explained it this way. Man, I don't like cake.
I love cake. I'll get it every chance I get.
I hate cake.
Especially on Saturdays.
Is there like a cake shop on Saturday?
Yeah. Cupcake.
Cupcakes are gross.
Not if they're made well.
Not if they're vanilla. Frosty is gross too.
Alright. Take a look at this guy. 2 minutes? Alright, let's bust through it real quick. Minus 81. Right? Or no? Divide by 4. Divide by 4. X squared equals 81 over 4. Take a square root. What's the square root of 81?
9.
9. Plus or minus 9. What's the square root of 4?
2.
X equals 9 over 2. Plus or minus. Okay? Next one, same thing. You add, so you have a 9, divide by 36. What's the square root of 9? Square root of 9?
3.
Square root of 36. Plus or minus 1/2. Done, son. This is cake. Alright, I'll wait on 33 because that's a long problem. So we'll wait on 33.
Wait.
What's up?